Yeah, everybody, thanks for coming. Originally, the title was about ascending somewhere, so I hope that you take your mountaineering gear with you. Maybe, no, speaker.
So let's begin with our agenda.
For the day, I will touch the ground with 3 use cases for Columnstar and describe the features that actually enable its use cases. And in the very end, if I have enough time, I will begin a discussion regarding potentially interesting feature on leveraging both MariaDB and Columnstore simultaneously on the same data. So let's begin with an overview for those who don't know what Columnar analytical engines are. Just very short overview. So, in a nutshell, Columnstore is an application that built on top of multiple layers. The first layer consists out of a MariaDB server that provides us with the MariaDB client protocol backends to support all the features and to produce the interfaces that are easy to use and can be used. After that, there is an intermediate layer open application that distributes the workload across multiple nodes that runs MLTP engine that tries to crunch the SQL query as fast as possible, just parallelizing and eating up all the resources available, all the CPU, all the RAM, and that's it. So there is also an additional storage layer that somehow stores data. We will get to the details to some degree. We will take a look at the details a bit later. But in a nutshell, this is what Columnstore is, an application behind MariaDB server. So the first use case, a very, I would say, usual use case for analytical databases. This is a mobile operators analytical software company. They wanted to save some bug and replace the existing closed source but very widely known OLAP engine. We will not calling names here with more cheaper and I would say they want to save money and at the same time they want to preserve the same level of functionality and stability. So these are their goals. And they bring a list of requirements and challenges for us. The sizes of the databases of the customers of theirs, because we actually they are a reseller that uses our engine inside their software. And their customers, they had databases that are usually sized from 10 terabytes, 20 terabytes, not as big, but something. And they are usual per day data ingestion sizes was like 3 terabytes of raw and compressed data. And they do these ingestions on a daily basis. And you can imagine they don't want to use cloud for security or whatever purposes, so this should be a standalone application for this. We use a bunch of features to fulfill their requirements. The first of them is the fast and versatile data ingestion that is built on top of a tool that I will mention on the next slides. Given that they need to quickly clean up after they ingest a lot of data, like they're moving fast, so they cannot and don't want to store lots of data, so we need to clean up the data in a fast manner. So they also use a partition management for the purpose to speed the things up. And you can imagine they are not only storing the data, they also query it, so they need a distributed and fast query execution. So with that, I will move to the first feature. Given that Columnstar is multi-node massively parallel application, we get somehow that is faster than a single thread data ingestion that MariaDB usually provides a custom LV. So for this purpose, we have an application called CP import. This is a standalone application that a user must run from a Linux console, unfortunately, and this console must reside on a server that is part of the cluster, of the Columnstore cluster itself. It is versatile in a way. It allows user to change the format of the data that it ingests. With the upcoming release, there will be new lower formats supported. As of now, is TSV or CSV. It can be compressed, as you can see on a second example. There is a way to pipe the input into this application and to use the compressed version of the data itself. And moreover, you can pipe the output from MariaDB query execution result itself to this tool. So this tool also has an ability to run in multiple nodes. I will not describe what all of these modes are, but I will touch the most interesting from my perspective, because it enables the sharded data ingestion. Let's say you have 3 servers and you want to ingest 3 terabytes of data, and given that you somehow prepare the data, your ETL already doing some batches, and you want to ingest data as fast as possible. So what do? You just divide this data batch into 3 parts and ingest in parallel all 3 servers separately. So given that you can alter the metadata that corresponds with the data itself independently, you can do this with CPU work. Unfortunately, as I mentioned, CP import is the tool that forces you to use Linux console, and you're not very familiar with that, or you just have restrictions. For example, in the cloud, you don't usually have access to the console itself. So what you do? You'll try to load data from your server, from your host, like using load data local file, for example. And under the hood, this command will leverage CP import nevertheless. But it will be, the data itself can reside on the user's side. So S3 is one of the next features that everybody widely use, and the modern software cannot avoid using it. Let's say people already have a batch of data, or their pipelines lands the data on S3. And you can use the data stored there to ingest it into Columnstore directly, either using the CP import native support for S3, or piping out the output for AVS tool itself. So you can ingest the data that is stored on S3 as well. And for convenience, we bring up the this UDF that you can call from a user interface, from either connector or MariaDB client connection itself, and it will do everything automatically and magically by itself. Under the hood, it leverages the existing Columnstore cluster management framework together with the CT or the S3 native support. The next feature that enables the software developer to manage with lots of data that it have is partition. And now we get to some technical stuff. Here you can see how the data storage layout is organized in Columnstore. On the very low level, there are blocks, and the blocks are basically a bunch of data that was 8 kilobytes. These blocks are organized into logical units called extents. That is roughly 8 million records. And these extents, they are together produce a so-called segment file. And let me remind you that we are talking about the columnar storage. So all this data, they don't, all these blocks and extents, they don't contain the records. They don't contain lights. They contain columnar values that belongs to a same column, So you guess what? We need to somehow organize the same the column values that belongs to the same records. And this organization, this logical unit, is called a partition. Like when you have, let's say, 50 or 100 columns, all these columns have a corresponding segment file that belongs to the line range, let's say, from 1 to 60 million. And after that, you have a bunch of segment files that actually corresponds a group of records from starting from 0 to 60 million. And this unit, the logical unit of 60 million rows, called a partition. So, what can you do with this organization? First of all, you can eventually. First of all, you can look at these partitions, and whether you are satisfied with what you see, you can actually leverage the information about min and max values in these partitions. Here is an example how you can query the existing operations access and plan how you can use it. So the min max values columns, they actually under the code used by Columnstore to filter the data. That is, I would say, semi-index. That's one of those scarce index types that are available for columnar databases. But moreover, you can actually clean up the data and use the min and max values for the purpose. As you can see, the current status of the partitions are all enabled. Yeah. And based on these min and maxes, you can actually, as I said, disable or clean up. And this cleanup will be a simple remove file operation. So pretty fast, comparing to a normal Davis operation that goes over this versioning and takes a lot of time. So with that, we will move to the second use case of Columnar, Columnstore, and this one is a merry story of a research company that was one of those who was behind the research of COVID vaccines. They actually leveraged the Columnar or Columnstore to run the genome research operations. I cannot get deeper into details. Nevertheless, when they arrived with the request to replace the existing research database that was based on a cluster of OLTP nodes, they have like a routine that takes 90 days to finish their research. That doesn't look appropriate. And given that we had a COVID pandemic at that time, they need to move faster. So their primary table that was used for the research purposes, it was 20 terabytes of data. And with Columnstore, they were able to reduce their I would say, usual query timings from 90 days to 8 hours. They are doing better now with a better hardware as far as So the challenges for the size of the single table that they were using for their research operations, and they actually need to migrate the data as fast as possible. Then normally it would take 5 days to migrate the data, but they were in the they were lacking they were lacking time a lot, so they decided to move faster, and for this purpose. They used the mentioned shipping protocol tree, like when they do the ingestion in parallel, that reduced the timings down to less than a day. It was 19 hours, if I'm not mistaken. So the features that they were using were the disk-based operation that allows them to reduce the targets from 90 days down to hours.
Sorry, how many nodes? Close the nodes.
Only three, but they're beating. Yeah, under the hood there is a huge storage. Actually, the storage is the most impressive thing. By default, the disk-based or external algorithms they are disabled to the Columnstore because like the customer would probably want to know when they turn on the slow disk-based algorithm. So this is how to enable them. And you can also change the temporary files path so you don't run out of disk space while running the disk algorithm. With that, let's move to the third use case, and that is a web marketing solution with a very peculiar usage pattern. One of their primary requests was to change as small as to make as small as possible changes to the existing application that was based also on OLTP. And this application, out of a sudden, I won't say exploited the insert operation too much, but given they were on OLTP, they can afford this. Now they probably have some concerns given that columnar databases, they are not very good running DML operations inserts and so on. So given that they want to stay with the application that just runs inserts as crazy, we have to suggest them to use the so-called the feature called insert cache. And they were using the fast delete operations as well to improve the speed of deletes, because as I said, the Columnar edges they are very, very bad with running insert updates and beats. Unfortunately, we didn't yet solve the problem with updates, but this is an interesting problem to solve in future. So, what is the insert cache? In a nutshell, this is a feature that user must enable explicitly in the configuration file, and you cannot do this online, so you have to restart the server, because I will explain why these are the right technical reasons for that. And on the lower gray area, you can see the improvements, like it actually delivers the timings that are comparable with MariaDB, and that might not look very impressive, like it's 2x or 3x slower to MariaDB, but if you take a look at the lower part of this gray zone, you will understand what I'm talking about. Naturally, the zone speed is 35x slower with the Columnstore comparing to MariaDB, so that's kind of improved, 10x improved. Here you go. Now let's get to the delete operation. How do we I will probably explain. They all an explanation why you cannot change this setting online. Actually, under the hood, this solution enables the temporary area table, so that when you insert the data into phone store table, for real, it inserts into area table first. And when a specific operation hits the table, it triggers the flush of the data into a Columnstore storage using this CP4 tool that I described previously. So this is why you have to enable it. And after this void, where these features enabled, every Columnstore table that you created actually consists of two tables, for code data and for not called. Let's say medium temperature data.
So the next feature, fast delete. Back in the time where this feature was not available, Columnstore during the read, it went through all the columns and mark the value in the column in the specific file for a specific row as deleted. You can imagine that it is slow, and even that in analytics, this is a huge, I would say, everybody wants to have a denormalized tables because joins are very costly when you run the operations on long tables. So you can have 500 column tables, 1,000 column tables. The worst that I have seen was that, and thousands. But I was said that this is not the worst piece. But anyways, what if you need to delete? What if with this algorithm that previously existed in Columnstore, you have to go over all the columns of this table, find the spot in the file, and mark them. That just sounds ridiculous, and it was ridiculous time-wise. So what you can see in these tables below, first you see the number of columns in the table. If I'm not mistaken, it doesn't actually matter what is the column type, to be honest. And the second column describes how much time would it take to delete 1 million rows. And you want to pay the attention to the difference between the column number 2 from the left and column number 4. And the last column would have this speed up. So you can see it's also delivers depending on the size, but we are also talking not billions here, billions of rows. I would say million is somehow small for Columnar format for Columnar storage. So this 1 million row delete is just to demonstrate the speed up. But if you run the delete operation for a bigger data set that is normal for Columnar storages, you will see a bigger improvement. But anyways, with the 50 columns, we have a 30x Pro. So that's also impressive. This enables that customer to actually run the software without too many changes. And they were happy about that. I don't know why. I mean, you can always rewrite software, but they prefer to rely on the database.
I feel we didn't touch on the stational on fast movie.
Say again?
How is it implemented?
Very straightforward. You have a column, a table have an auxiliary column. That's basically 1 byte column as of now, and you have 1 bit that describes a marker for the row is delete.
Okay, sorry, I thought there was 3 implementation. Yeah, sorry.
No, yeah,
So BSC is the set.
yeah. So this is 1 column, and there is a marker bit of being delete, and we actually read it before we read the data itself. So it's kind of index that is involved in scan operation.
But you have approach 1 and approach 2. That confused me. So we are.
Yeah. That's actually the data between 2 and 3, the columns 2 and 3 from the left was mentioned just
To demonstrate there is a speed up appeal this too, because the auxiliary column implementation, it has to demonstrate that it is not slower than the second column. It's just a research approach, the scientific approach. So with this section, I would invite a couple of people from the auditory to start a discussion
about potential use case for Columnstore. So cross-engine joins, what is this in a nutshell? We see. Yeah, let me try to describe using this slide. This army query is actually TPCHQ21. It consists of a number of record joins combined with the fuses built on top of semi-joins. So if you pay attention to the second union subquery, you will see the structure, like a couple of tables mentioned in from cross and two joint fibers. So in a nutshell, cross-engine join feature allows to, let's say, replace the smaller nation and supplier tables that in the case of scale factor 10 should worth like up to 100 bytes or something. And you can put these tables that are called in a star schema approach dictionaries or dimensions. You can put that into using in a decay table. So let's assume that there are some tables that change fast, and you want to have all the benefits of using ENVB engine, but line item and orders are huge when you don't want to store them in, for some reason, you don't want to store them in a ZD. So with this, you can actually mention multiple engine tables in a single query. And this query will be handled by Columnstore itself, and what it does to process the data that belongs to different engine. Under the hood, it establishes the client connection to the server and retrieves the data that it needs to proceed with these query executions. So this is what the feature is in a nutshell, and this is how to enable it. Like you are setting what is the host name and the credentials to access the client, to access the server. You can optionally store the password in an encrypted form so that it is secure and nice. What if with this feature we actually don't have any Columnstore table at all? Like what if all of the data belongs to MariaDB? Here's the example how this can be implemented with the existing Columnstore and MariaDB. That should be 10.6.20. And the green are the markers for the times. So the time is in a little, that is 30 seconds, 30 seconds. That's resolved from in the table, run the query that is one line above on these green timings. Pretty simple. The population and the TBL for the table can see about. And on the second or the lower half, you see this early query that is actually a combination or a trick to force MariaDB server to push the query into Columnstore, like calling a Columnstore table with an impossible condition, so that no data will come from this table. And the second union part, it actually consists of a bunch of subqueries that leverages partition. But what happens, you can see the timings, they are not very impressive, like 11 seconds against 13, but not very impressive. But what happens under the hood? This query demonstrates how you can actually parallelize the query scan, the data scan from inner DB tables. Like we are using mail leveraging partition in the union part, querying the parts separately. Because every subquery in this union, these will be retrieved, the batches will be retrieved in parallel from inner DB. And after that, Columnstore will hand this data, hand this batch over to the group by operator that's run by Columnstore itself. And Columnstore, it runs, I remind you, it runs every algorithm in parallel. So it can do faster than MariaDB or MariaDB as of now. So my suggestion is to try to, it's not a suggestion, actually we run this query. If you saw the 2-second improvement, here we are talking about tens of rates. Like the original query, if you remove all these arg4 and add appropriate indices, your query was like 34 minutes to run on DPC scale factor 10. But with these ugly rewrites, we will have, despite it is ugly, we will have 50 or 15 or 15 point something minutes. So kind of more than 2 times. And this is only scale factor 10. So we are talking about 10 gigabyte day worth of data. So this is where I need the support from the server team, because to actually enable this feature, we need a more clear solution to deliver the data, or the newer typological solution that can be used by our customers and open source users. So with that, I will thank you very much for listening. You stop and I will teach.
Thank you, Rohan. Nozdrin.